you hear that?
That was crazy, man.
That came from outside.
So today we're talking all about global winds, and just to kind of give you a quick gist about what a global wind is, basically they're huge systems of moving air that cover the entire Earth. We're not talking about just like wind blowing through your backyard. We're talking about winds that wrap around the entire planet.
Goes across oceans and continents.
Yep. And there are basically 6 major belts of wind that encircle the Earth. 3 are in the northern hemisphere, and 3 are in the southern hemisphere.
Someone call these the trade winds.
That is true. Probably had something to do with the whole trade routes.
You've ever seen the movie Castaway?
Yes, and
You knew a lot about the trade winds.
Yep.
Yes.
Blowing
And there are
ships around the world.
And there are the belts of winds, by the way. You got what are called the westerlies.
Yep.
And those are winds that blow from west to east.
Yep.
You probably have something called the easterlies.
Easterlies, or the polar easterlies,
And they
because
go
they're at the
from
poles.
Yep.
east to west.
East to west. Then you got the trade winds, which are in the middle, and this fun little area called the doldrums.
Mm-hmm. And we'll talk about that.
Doldrums.
Yep. So before we get too deep into talking about the different types of winds, we should probably reiterate and mention the fact that the Earth's surface is curved, which means
Right.
that each area receives different amounts of radiation because the light gets bent across everything.
You guys know
Right?
that.
We should. So there's more heat at the equator, less dense, moist, rising air there, so it's hotter, so it rises up. There's less heat at the poles, so it's colder, so it sinks. So you got rising air from the equator, sinking air at the poles in general.
Oh, something that goes around. We had this when we talked about magma, didn't we?
Yeah,
for
or
those of you
magma.
who don't want to laugh at me, magma.
Yeah.
Or the lava lamp that we did.
Yes.
Or didn't we do this with something else?
Any
too?
kind of current going in a circle is a
Maybe.
convection current, and
Right.
in this case, it's circular airflow.
True.
Rising warm
Hot
air
up,
goes up,
cools,
cold
falls.
comes down. It's the same thing again. We're seeing
Up,
these
down.
patterns over and over again in different parts of nature.
Yay. And there's this thing called the tropopause, which is basically the top part of where those hit.
Yep, the troposphere, it pauses and drops.
Okay.
Let's talk about 3 causes of global winds. First one is what we just talked about, guys. It's convection currents.
Yep.
And that's just wind caused by temperature differences. Hot air
Hot,
rises, cold air sinks.
Remember though, it doesn't just go straight up and down.
No,
Nope,
it's like-
It goes
it's a
up,
curve.
and then it gets pushed
Pushed,
off by this
yep.
other
Yep.
stuff coming up,
And
and then when it
down.
goes down, the stuff that sinks also gets pushed. So
Yep.
that stuff
That
that's on the
causes that
surface is
circular
going.
motion. It's not like this. It's this
Right.
circular
Big
motion.
circle.
Now, we also have the rotation of the Earth. The Earth is spinning about 1,000 miles an hour, and wind is caused by that moving atmosphere because the atmosphere is particles, it's airs and gases and some solids, and it moves, and it causes wind.
Mm-hmm.
Cool. If the Earth didn't rotate, all the winds would go directly towards the equator. But does it?
No.
Rotate. Oh.
No.
Yay! No, because the Earth is rotating, it actually does not all get directly
Yeah, because
pushed
otherwise
towards the
everything would
equator.
drop down there, and there'd be a lot more air around the equator, a lot denser air around the equator than there currently is.
And everything else would pretty much be horrible.
Yes, so the spinning actually gives us this aid in convection current.
Yep.
And we're going to look at how those things break up. There's a neat little effect we're going to talk about called the Coriolis
Ooh,
effect.
I like the Coriolis
Yeah.
effect.
And what
Take
it
it
says
away.
is this. There's 3 little parts of the Coriolis effect. So remember, this is the 3rd cause of global winds. And this 3rd cause is broken down in 3 parts. First, we have air masses that rotate clockwise in the northern hemisphere. So that's
Are you
like,
going clockwise to the camera?
yeah, that's
now
hard to
you
tell.
are.
That's northern hemisphere is the United States. It's where we live. So we're not talking South America. We're talking about like most of Europe, United States, Canada,
Yep.
Japan, those places. Air masses rotate counterclockwise, so in the opposite direction that clock hands go in the southern hemisphere. So if you're in South America, if you're down there in Australia or on the South Pole, then the air masses rotate the opposite direction
Yep.
that clock hands go. And then here's the big part. These currents get broken up about every 30 degrees. Remember, latitude comes back.
Yep.
Every 30 degrees going up north or going south, you get like a little pocket going around, and then you go 30 degrees up in another pocket, and it's an approximate, but it's not just one big blanket of air. And that Coriolis effect says we got like these donuts of air going around the Earth.
Wrapping
And there's
around the
3 in the northern hemisphere and approximately 3 in the southern hemisphere, and that makes those 6 big, giant, global
Winds.
pockets of air.
So, big thing, end result here is that the Coriolis effect is due to the Earth's
Yeah,
rotation.
if the Earth didn't move, we would not have this kind of effect, and it's awesome that it does because we can breathe.
Yeah, it kind of curves the winds, right?
Yes.
That's why we see those curved lines.
Apples grow.
You really just take a bite out of an apple
I
for
did.
your video?
I did.
So anyway, In the United States, we experience something called the westerlies, and those are. Hold on, can I use this paper so I have a mouse pad? All right. So anyway, the westerlies are right here. The air moves from the west to the east,
Which is why all of our weather moves that way.
Yeah, and believe it or not, that's actually, if you look at this chart, only this part and this part of the Earth have that effect.
Mm-hmm.
If you go to a lot of other places of the world, like I haven't experienced this traveling abroad, but it would seem
neither.
weird to me because I'm so used to weather coming from the west that there's some areas of the world where their weather's coming from the east. In fact, even at the southern tip of Florida, their weather does
Yes.
kind of come from the east.
A little
Yep.
bit, yep. That's how.
Yeah.
That's why
Of
they
course,
get a lot
I
of.
wasn't
out of the
tuned into
Atlantic,
that the
yeah.
one time I went to Florida, but yeah,
Yeah.
It's cool though.
it's all just
So,
nice
and that's
there.
that Coriolis effect we're talking about, where it's about every 30 degrees. You can see on there 0 to 30, 30 to 60, 30 to 90, they change directions, and then you can go south and get the same thing.
Right.
And then the trade winds, since they both basically push towards the wind to the equator.
Yep.
And then these equatorial doldrums actually have no winds.
Yeah.
It's extremely calm. In fact, back in the day when they had to rely on trade winds, would I just ruin it for you? You can take it.
No,
Oh.
no.
So sailors tried to avoid these doldrums.
'Cause
It
they
actually
get
varies based on season because the
Yep.
Earth does kind of the
Yep.
equator changes as far as wind goes, but we won't go into that so much. But
Yeah.
anyway, sailors would be afraid of getting stuck at the equator because there's no wind there.
And they'd
Yeah,
be
their ships were
stuck.
powered by sails.
Yeah, and they basically have to
And
wait until like
it's
2 months
basically-
later when the wind would.
Yeah,
And they'd
air
probably have to
collisions against
resort
their
to
sails.
cannibalism.
It's air collision against their sails, which is actually going to push their boat. So here at the doldrums, you have the northeast trade winds and you have the southeast trade winds collide, and it's that destructive interference.
Cancels them out.
They cancel out each other, and there's really not much wind at all to be measured there, and
Nope.
the ships just won't move because nothing is pushing against their sails. No wind to blow, they don't move.
True.
Right.
Pretty brutal.
So this diagram here matches one magically
Yes.
in
your
your
notes.
packet. I know it's
Yeah,
amazing.
look at that. Label this
And
critter up.
Basically, we're going to kind of go through and label it, but real quick, I want to remind you, air masses curve to the right or clockwise in the northern hemisphere,
Yep, and you
and
saw
they
this already.
curve to the left or counterclockwise in the
In
southern,
the southern
hemisphere,
hemisphere, guys.
which is a very key thing.
Yes.
So make sure you label that diagram.
You'll have polar easterlies, and you're going to see them at the North Pole and the South Pole. Then if we're squishing in, you're going to get the westerlies, which means that the wind on that part in the next 30 degrees will be turning in a westerly fashion. And then if you get closer, you're going to get the trade wind of the northeast. There we go.
Yeah, I was
Woo!
hoping you'd catch it.
Wind.
I wasn't looking back
Awesome.
at you guys, so sorry.
So that's kind of how this whole thing breaks down. Again, we talked about 6 wind patterns here. It's caused by the spinning of the Earth. It's called
1,
the Coriolis
2, 3,
effect.
4, 5, 6.
One more than I have fingers.
Yes. Yes, but not.
And now we're
that's
done.
right. All right. Do your checkpoint, guys.
Checkpoint.
And also, eat apples.